All right, let's get back to our algebra. I hope you had a good break. And we're going to be starting off really simply. This may be slightly a review. The term here is writing sums as products. So what does that mean? Here it says sums of identical terms can be written using product notation. Now, what the heck in the world does that mean? Well, let's have a look at this. It's actually much simpler than what we would think. We have this problem, 3 plus 3 plus 3 plus 3. And we know that 3 plus 3 plus 3 plus 3 equals 12. We also know there are 4 groups of 3. Okay? So it is the same as 4 times 3, which we have written right here. So 3 plus 3 plus 3 plus 3 equals 4 times 3. In other words, as I mentioned here, 4 lots of 3. That makes sense? 4 groups of 3. Well, we can do that with letters and terms. So here we have an example of a B plus a B plus a B plus a B. Now, we do not know what B's are, but we do know that there are actually 4 B's. Here's 1, 2, 3, 4. There are 4 B's. So we could write this expression as 4 times B, which equals 4B. Okay? 4B is the same as, for example, what we wrote here. There are 4 groups of 3, so 4 times 3. Here there are 4 groups of B, so that's 4 times B. That's 4B. This is product notation. We have this example here of R plus R plus R plus S plus S. So altogether, we have 3 R's and 2 S's. And we can see how they did it right here. There are 3 R's and there are 3 S's. So it's a plus sign in the middle. On the other side, number B, we have D, plus D. Ooh, and then we go to a minus, a little bad minus. And then we have these A plus A plus A plus A. Okay, how do we write that? Well, we do not know what D is, we do not know what A is, but we do know that there are actually 2 D's. So we have 2 D's. And we know there are 1, 2, 3, 4. There are 4 A's. And in between them is a negative sign. See that little negative? And it stays like that. So we have 2D minus 4A. This is super simple stuff. This is writing sums as products. Now let's have a look at index notation. It is a way to simplify algebraic expressions the way we did it for numbers. So here, though, we have not, rather than adding 3 plus 3 plus 3 plus 3, we're multiplying. And we know that 3 times 3 times 3 times 3 equals 3 to the power of 4. Okay, if you use your calculator, you're going to get the same answer. 3 times 3 is 9, 9 times 3 is 27, and who can do the math? 27 times 3 is 6, 7, 81. So we know that this is 81. 3 times 3 times 3 times 2 is 81, or 3 to the power of 4 is 81. Here on the other side, we have B times B times B times B. There's 4 of them. They're not adding, they're multiplying. So that's the same as B4. If we use this as a number, let's say we said 2. Let's say we said 2 times 2 times 2. Okay. Now I like to put a dot rather than an X because in algebra now we have a lot of X's, and sometimes you can mistake an X for a multiplication sign. And it gets really confusing. So we always write a little dot rather get into that. 2 times 2 times 2, which actually equals 2 times 4 is 8. 8 times 2 is 2 times 2 is 4. 4 times 2 is 8. So this equals 8. This also equals 2 to the power of 3. There are 3 of them. There are 3 2's that are multiplying together, and so that's the same as 2 to the power of 3. All right, and so here they have some examples. We have 1, 8, and then we have a 1b, 2b, okay? And then we have these a's. I'll make a different color here. So all together, we have an 8. We only have one letter, excuse me. We have 3 a's, so a to the power of 3, and we have b to the power of 2. And if you notice, we always put the A, like the A, it's alphabetical order. So when you may wonder why they've switched the A in front of the B. It's because it's alphabetical order. So when we're writing this out, we always put the first letter first. Here on the other side, okay, we have K, we have 2 K's, and we're adding them. Then we're subtracting a 3, and then we're multiplying 3 D's. Ooh! So what that happens is now we have 2 K's, okay, and we have our little subtraction sign right here, and our 3, and then we have D to the power of 3. All right. Be careful when you have like a letter K plus K. Be careful not to write this because it's very different. K plus K is 2K. It's very different. If this was, for example, 6, right? That would be 6 plus 6 is not 6 square. Okay, 6 plus 6 is 12. Or it also equals 2 times 6, which is 12, same thing. But it is not 6 to the power of 2. I hope that makes sense.